For designing parabolas. So we're given the quadratic function negative 2x squared plus 3. So in this case, we have a is negative 2, b would be a 0 that's not really there. So let me write this a little bit better. So think about our function is equivalent to negative 2x squared plus 0x plus 3. So your a is negative 2, your b is equal to 0, but c is equal to 3. And then let's plug in our little axis of symmetry formula. So negative b would be negative 0 for this example, over 2 times a, which is negative 2. And so then 0 divided by anything would just be 0. So our axis of symmetry is right at the y-axis, because that's where x equals 0. So let's sketch that. And then we're going to use that value to help us figure out the vertex. So we're going to plug in x equals 0 into our original function. And simplify. So negative 2 times 0 squared would just be 0. And then plus 3 is just 3. And then we can write our vertex. So our x was 0 and y is equal to 3. And so that is sitting right on the y-axis. So if we go up 3 and put our vertex, then when we go to pick out our y-intercept, for this one, notice our y-intercept of 3 is already where our vertex is sitting. So they're actually the same point. So we're going to use our axis of symmetry again, but we need to use it a little more than we did on the past examples to help us find another point to graph. So let's pick out a value for x that would be simple to plug in, like 1. So if we have x equals 1, we just need another point on our graph. So let's plug that into the original function, which was y equals negative 2x squared plus 3. So that would be negative 2 times 1 squared plus 3, which is negative 2 times 1 plus 3, which is negative 2 plus 3. So it all simplifies to just equal 1. So we're just using that same concept that you can pick out an x and plug it in to figure out a y value that would be on our graph. So the point we found on our graph is 1, 1. So now you can plot that point and use your axis of symmetry to plot the point that's opposite that one. And then we can draw our parabola. Alright, so that just took a little extra work to figure out another point, because we need at least 3 points to have a good graph. So your domain is how far this graph goes left and right. So just like we've been talking about, that would be all real numbers because it goes left and right forever. And then the range is how far your graph goes up or down. So this graph has a highest point at y equals 3. So we would say y can be anything less than or equal to 3, but it won't be anything bigger than that. And let's just label one more thing. This was a maximum vertex. So it's good to realize that when it's the highest point on your graph, it's called a maximum point. All right, so that's it for example 4.